This video will show some basic capabilities of sending and receiving data on an ARINC429 avionics data bus using hardware and PBA.pro software from AIM. To begin with, we'll set up a simple outgoing data pattern on a transmit channel. We'll start with a label list, which is essentially a list of messages to be transmitted. Each label designates a message with a predefined meaning. Upon inserting a transmit label or message, default values are assigned for the message label, rate, queue size, etc. For the data payload, sometimes called the value, we will use a dynamic tag function to assign a simple series of ascending integers. This completes the setup of our example. Now we'd like to see the outgoing message, so in the activity section we can call up a binary display of the message. And then we turn on channel 1, which starts the messages going out on the wire. You can see the ascending integers in the data payload in the binary display window from a moment ago. What about receiving incoming messages? Well, for this example, we have connected channel 1 transmit to channel 5 receive. So we can enable channel 5 to receive, and here on the status property we can open a window that shows activity. Turn on channel 5 and we see the message count immediately start ascending. Navigating to capture, activity, and label 0 allows us to view the binary display of incoming data. You can see that the data received on channel 5 matches the data going out on channel 1. The standard display provides activity information for channel 5 and likewise for channel 1. Note the message count on channel 1 is higher because it had already sent out hundreds of messages by the time channel 5 was turned on. The bus monitor recording display shows each individual message with more details, including the timestamp with microsecond resolution and the elapsed time since the previous entry. Basic sending and receiving of data on ARINC429 is that easy. Let's have a look at a slightly more involved example in which we use the PBA.pro database manager to interpret the raw binary data. For this example, we will simulate transmitting and receiving of a message defined in the ARINC429 specification. The message of interest will be associated with equipment ID 705, attitude and heading reference system, and label 325, roll angle. Of course, this example can be tailored to include multiple labels from any equipment ID. We start by loading 6,000 different labels for dozens of equipment IDs, and then navigate to the Parameters tab here on the left edge of PBA.pro. Then we will snip out all the ones we are not interested in, which is all the equipment IDs except for 705. Once that is done, we can open up equipment ID 705 and snip out all the labels except for 325 roll angle. Conceptually, the database is comprised of stream IDs, each of which usually represents one equipment ID. The 705 attitude and heading reference system was assigned to stream ID 5. But the stream ID can be any number since the identification is just an abstract number. For instance, we can change it to 17. Similar to the database concept of stream IDs, which map to equipment IDs, there are database channel IDs, which map to physical ARINC429 channels. As before, the channel IDs are abstract identifying numbers and they are not required to match the physical channel number. The label 325 roll angle is part of channel ID 1, but we could change that ID to say 42. And later we'll see how the database channel ID 42 can be mapped to any physical ARINC429 channel. Okay, we've deleted thousands of unwanted label IDs and equipment IDs, and also made a couple of edits. We should save the database as depicted here. We return to the Resources tab on the left edge of the PBA.pro window. Selecting the A429 board 1 allows us to change parameters associated with that particular piece of hardware. In this case, we want to associate this A429 board with database stream ID 17 which is the stream ID in our modified database. Now we set up channel 1 to be a transmitter, as we did in the previous example, and also we changed the database channel ID to 42, thus associating physical channel 1 with database channel ID 42. And on the context menu for physical channel 1, we choose Sync with Parameters to bind it with database channel ID 42. Expanding under the Send and Setup icons shows how we now have roll angle, label 325, assigned to channel 1. What this means is that any data bits going out on channel 1 will be interpreted by PBA.pro in accordance with the database entry for roll angle, label 325. We can open an Assign window and drag all the roll angle parameters into it. Each subfield of label 325 is interpreted based on the database definitions, so the SSM bits can easily be adjusted from failure warning to normal operation. The roll angle itself can be assigned a formula that is a little more interesting than the ascending integers of the previous example. Using the f of x operator, we can type in a formula. In this case, it'll be data in the shape of a sine wave. We click to start the assign window and the roll angle begins updating according to the formula we just typed in, while the database maps the floating point number, the roll angle, to the bits in the label 325 message. The transmit activity binary display shows the outgoing message. We can turn on the receive channel 5 and switch its database channel ID to 42, just like we did for channel 1. Then start the receive channel and look at the activity. In this case, we want to see a plot of the incoming data. Selecting auto-adapting Y range gives the proper vertical extent for the plot. As before, the recording display of the bus monitor function shows a summary of everything that is going on. These examples have included both transmit and receive, but just the transmit half of the example, or just the receive half, is useful for diagnostics, development, and debugging of actual ARINC429 equipment.